All right, this is the last set of notes for topic B for digital electronics. Today we're going to talk about global standards that are used for the designing and application and use of electronic products. Now, global standards are important in that if you don't have standards for electronics, then you basically have a bunch of pieces of electronics that only work in isolation. For example, one standard that's commonly been used since electronics have been developed has been using binary, digital signals of ones and zeros for text, voice, and graphic communication. This allows you to use electrical lines to transmit and allows you to use fiber optic lines to transmit where you're just sending pulses, usually a low pulse and a high pulse for a 1 and a 0. Typically it's not completely on and completely off, because when you have a connection link, a lot of times completely off means the link has been severed. So you typically actually have three states. A low power, a high power, and then off indicates that there's no connection anymore. Now in text, for text in the United States, they developed something called the American Standard Code for Internet Information Interchange, also known as ASCII. You've probably heard about ASCII or seen ASCII. Have you spent any amount of time on the internet? It was developed back in the 60s for the old teletype machines and the old basically kind of punch card type machines. Since teletype systems aren't used anymore, ASCII is kind of obsolete, and you'll see why in a minute. Now, ASCII was replaced in 2007 by something called UTF-8, which is a 8-bit coding system. Okay, UTF is Universal Transformational Format, or UCS. I'm sorry, UCS, which is so. Let me restate this. UTF is an acronym that starts with another acronym. Okay, so UTF stands for UCS Transformational Format. UCS stands for Universal Character Set. So an acronym of an acronym. Now, colloquially, which I use that word a lot in these videos if you pay attention, it is referred to as Unicode. Okay. Unicode, it's an international standard over ASCII. Now, it uses 1 byte of information. ASCII can encode 128 possible symbols. UTF has a variable width, so there is no limit in the number of symbols that it can encode, but it takes up as many bytes as it needs. Typically, 2 bytes is enough, and 2 bytes provides over 64,000 symbols, which that's enough for every character of every language on Earth. No problem. Almost all alphabets, but handles quite a few of them. Now this chart right here is from the 60s, as you can tell. If you can see this, it looks like it's from the 60s. This is the original ASCII code chart, and it shows the binary code for each of these symbols. So 0000 is a null, which is, like I said, no link. And then you have, these are going down different character sets, or different, rather, symbols that are used for the code. Now, companies can use a generic data system or develop their own data system. If they use a generic data system, then that system is going to be universal with other companies. If they develop something proprietary, then obviously other companies usually won't use this. Usually won't use their system because a lot of times they'll have to pay a licensing fee, and typically companies don't want to do that when a free version exists that does exactly what they need it to do. So they're not going to license some system from a different company when they can just use a generic non-proprietary version. Now, if you rely on a standard, if a company relies on a standard format, then they're going to have easier adoption. So if you, let's say you had you invented a digital camera. Now, typically, what's the format that digital cameras will output? Come on, you guys are aware of this sort of thing. Images. What type of pictures did digital camera output? File type. JPEG. JPG. Okay, that's an example. You all know what a JPEG image is, right?
What does PNG?
Now, PNG is portable network graphic. It's basically kind of an open JPEG. When it was originally developed, was a proprietary format, but the licensing on JPEGs has lapsed. So now it's open to anyone. PNG was originally developed as a slightly higher quality alternative to JPEGs that was an open format. So in the early 2000s, a lot of companies were going from JPEG to PNG because they had to pay licensing fees to use JPGs. Now you don't have to anymore. So either format works. It's known as a lossy compression technique. Might get into that in more detail later. But anyway, going back to what we were talking about, so if you developed a digital camera that used a JPEG format, you could open that file type on any device, right? If you used a digital camera that used a proprietary format that you had to purchase a special program to use on your computer to be able to view those images, and then the images on a camera were only viewable on the camera itself, unless you had that special program, how many people do you think would go out and buy this camera? Not that many, because you'd be locking them in only to a specific format. If you use an open format that anyone can use, you have a lot better adoption rate. Another standard was MP3s. You guys have heard of those, right? MP3 files was a compressed audio standard developed in the early 90s, but there were limitations in the sound quality, and it was developed originally as an open format. In 1997, a new format was developed called AAC as a successor, and a lot of one of the ways that companies who were developing AAC files and who were developing software and hardware for the new format, what they did was to get more people to adopt their software, they made the software and hardware backwards compatible, which means it would open up the new AAC format, but it would also open up the old MP3 formats. Okay, that way they didn't lock out customers who had bought or ripped or whatever millions of MP3 files, and now they weren't able to use those. Now, Apple's iPod product and any iDevice product really supports old generic formats like MP3, more modern ones like AAC, and then it also supports DRM locked proprietary formats that are available on iTunes. There are other DRM. Do you know what DRM stands for? Have you heard the term DRM? Digital rights management. Basically, when you download a file through a program like iTunes and you load it on your iPod and you listen to it and you're like, okay, I want to transfer this file to another computer, and you can't open it up on another computer, it says something about rights management, that's DRM. The purpose of DRM is so you can't easily copy software, or in this case audio files, from one computer to the next. Okay, it's kind of put into place to prevent piracy. Does it work? For most people, yes, but there's ways around everything. Okay, and a lot of people have spent a lot of time coming up with ways around DRM. So much so that DRM is one of those things that's kind of starting to fade out a little bit as companies realize that it's a kind of like Sisyphus. Okay, you know who Sisyphus is? It's a constant struggle that is never going to end. So the best way is to figure out a different way around things, or a different way to deal with it. If you consider how standards have impacted equipment like cell phones and media players, with the standardization of those JPEG files, imagine if every phone that was out there, when you took a picture of anything with that phone, it was only viewable on that phone. In other words, you took a picture with your phone and you emailed it to someone else, or MMS messaged it to someone else. They couldn't open it because they didn't have your phone. Would that make that particularly useful? No. In other words, we wouldn't have to worry about idiots taking selfies and whacking people with selfie sticks. Now, for the consumer, or actually for the manufacturer, using generic standards reduces the cost of research and development because they don't have to develop new formats. They can just use what's already out there. Plus, you get more product loyalty if someone can use your product in addition to other products. You can dramatically reduce your costs when you use pre-existing standards versus trying to develop your own systems. For the user, then a person, if you're using this technology, then it's also going to reduce your costs. How many of you guys have a cell phone in your pocket that charges using a micro USB charger? You know, I'm talking about the little. If you know for a fact you can use someone else's cell phone charger to charge your phone, not like an off-brand one. Okay, there's quite a few of you who have a standard format, and USB is one of those standards that has been developed for a lot of things. If you look at video game controllers, like I know for the PS3, it charges off of a mini USB. Okay, there's other Xbox One does as well. So it uses this standard format, and it can be standardized because it's a standard shape for the controller, but also USB provides a consistent 5 volts. Okay, they're talking about before. Remember how we were talking about different outlets in different countries? How you go to one country and you have one shape of outlet and one voltage and one AC frequency. The funny thing is, over the development of its lifetime, USB has become the true international power plug. Because if you use a USB port in this country, it's 5 volts. If you use a USB port in France, it's 5 volts. If you use a USB port in New Zealand, it's 5 volts consistently across the board. So USB has done more for data connection, or done more for power than it has done for data connections. Discuss the implications of company-specific standards across the marketplace. For example, an example of a company-specific standard would be the Lightning charger, okay, from Apple. The Lightning charger is capable of charging what devices? Anything that starts with an I, but it's consistent across that brand, with the exception of the iPad, because the iPad draws a little bit over 2 amps of power, and the iPhone chargers don't provide a full 2 amps of power. So you can charge an iPad on an iPhone charger, but it takes longer, right? I have no Apple products at home.
Minis have the same as the cell phones.
So it's the power draw. The full-size iPads draw a lot more power. So there's a higher current requirement. Okay. Now, for a long time, the only Lightning chargers were available directly through Apple. I don't know if that's still the case, but with the older generation of chargers, they actually licensed them to third-party manufacturers. So you had other companies making iPhone chargers.
I have one that's not Apple.
Right.
Belgian.
So that explains all of that. That is the end of our notes for electronics. Congratulations.